Hello, we are Group D. Our project is a smart chair for office environments using novel fabric sensors. Desk chair use can lead to many different health issues over working life, with the average person spending 5 hours a day seated at work. Health and safety executives state that 6.5 million working days are lost due to work-related musculoskeletal disorders each year. 11% of these come solely from desk work. It is therefore clear that there is a desire to help mitigate and reduce these injuries in the workplace. Society is becoming more technology and health oriented, and hence there is a growing trend to attempt to measure and collect data to gain insight into the indicators of a healthy lifestyle. Working and office lifestyle is a huge part of people's lives, where they spend numerous hours a week sitting at a desk. Can technology be used to investigate the long-term effects of this lifestyle and potentially give feedback to help eliminate bad seating habits?
The project was split into three subsystems: the chair, the user's PC and the server. The diagram here illustrates the connections between these different subsystems and what each one contains. The sensors are wired into a PCB containing the measurement circuitry. This then feeds into the microcontroller, which transmits the data to the user's PC using a communications module. A program containing the classification algorithm and user interface will be running on the user's PC to display real-time feedback based on sensor outputs.
The bespoke sensor array is woven onto a sheet of fabric using conductive thread in a 3x3 grid to create 9 resistive sensors. Each sensor has a nominal resistance of around 200 ohms, which decreases by around 50% when pressure is applied. A simple voltage divider circuit is used to measure the change in resistance when a pressure is applied. 3 standard off-the-shelf resistive sensors are used in the back of the chair, given only one sheet of fabric sensors was available. These again use a voltage divider circuit. Based on these two circuits, a PCB was designed and constructed, allowing the circuits to be easily attached to the mobile chair.
A testing strategy was developed to identify differences in user seating positions. Users were asked to sit in 10 different seating positions, and this was used to train a classification algorithm. When looking at the new data analysing on a computer, we found an accuracy of around about 70% for classification using 23 nearest neighbours. This was further increased by lowering the number of nearest neighbours to allow for data to be optimally fit, since the algorithm itself doesn't have any way to optimise the number of nearest neighbours. A classification algorithm is used, and that will identify the differences in user seating positions by identifying key characteristics of loads that are measured on the chair.
Our Smart Chair project effectively provides research into these new fabric sensors while also operating as a potential method of eliminating bad seating habits and workplace injuries.